Hi guys, today we're finding an x-intercept of a quadratic equation. So there are 4 steps that we can use to help us find x-intercepts. Step number 1 is to plug in 0 into your equation wherever you see a y. Second step, you're going to factor, and there were 5 ways that we learned to factor: GCF, dots, GCF and dots, Punnett square, and GCF and Punnett square. Third step is our zero product property, which you guys learned last class. And then our fourth step is to write our answers as coordinates, which looks like your number that you find, comma, 0, because they're x-intercepts. So we're going to try and do a couple together. We're going to start with problem number 1, which is y equals 4x squared minus 36. Notice that I put those 4 steps on the corner just so that we can refer back to them as we go through each of these problems. So step number 1, let's start by plugging in 0 into your equation for y. So instead of writing y equals, I'm going to have now 0 equals 4x squared minus 36. And again, that's because we're trying to find an x-intercept, so we have to plug in 0 for y. Step number 2 asks us to factor. So we always want to start by looking for a greatest common factor when we do factoring. And in this case, I do see a greatest common factor because we can pull out the number 4. So I'm going to pull out a 4, and when I bring out the greatest common factor of 4, I'm just left with, in my parentheses, x squared minus 9. And again, that's still equal to 0. Once I'm done pulling out the greatest common factor, I want to ask myself, am I done? Or does this look like I can do dots? Or does this look like I can do a Punnett square? Well, I can't do a Punnett square here because there aren't 3 terms in my problem. But remember that dots is a difference, meaning we have to have a minus sign, which we do, of 2. There are 2 terms inside of my parentheses, and they're both perfect squares. So I'm going to go ahead and factor that using dots. Don't forget, your greatest common factor of 4 must stay out front. And then we can break this down. So x squared is really just x and x, and 9 is really just 3 times 3. So when I dots this inside of my parentheses, and I'm going to move that second step down a little bit, I get, in my parentheses, an x plus 3 and an x minus 3. Both parentheses get the same thing, but one has a plus sign, the other has a minus sign. So that was step number 2. I factored using my GCF and dots. And again, each problem is going to be different depending on what you have, but you're going to factor in one of those ways that we have on our list. Step number 3, the zero product property. So that tells us that each piece, when I multiply them together, could be equal to 0. So I'm going to set each of my pieces equal to 0. When I do this, I like to kind of separate them so that I have a space for all 3 of my pieces to go. So the first one is 0 equals 4, and we know that that's not true, so that's not going to be one of our x-intercepts. The second piece, I have 0 equals x plus 3. And my last piece is 0 equals x minus 3. Now I can actually do some math in these last 2 pieces. So I'm going to subtract 3 on this side. And that leaves me with x equals negative 3. And on this other one, I'm going to add 3 to both sides. So that leaves me with x equals positive 3, or 3 equals x, doesn't matter how you write it. But now that I have these 2 answers are going to turn into my x-intercepts. So last step, step number 4, write the answers as coordinates. So in our first one, we said x equals negative 3, and remember y is 0, because we plugged in 0 for y at the very beginning. And same thing here, I have x this time equals positive 3, comma, and our y value again is 0. So my 2 x-intercepts, or your 2 final answers, are negative 3, comma 0 and positive 3, comma 0. So if we were to graph this parabola, your x-intercepts would be at negative 3, comma 0 and positive 3, comma 0. All right, let's try another one together. Again, I have that list up on the side for us to refer back to as we go through this problem. So this equation, first step, we want to take 0 and plug it in for y because we're trying to find an x-intercept. So I'm just going to replace y with 0 and rewrite this entire equation. So that was step number 1. Step number 2, we're going to factor. So when I look at this, 2, 7, and 15, there is not a greatest common factor here. So I'm going to then look to see, is this dots? Remember, dots is a difference of 2 squares, but we have 3 pieces in this trinomial. We have 1, 2, 3. So this is not a dots problem, which means it has to be a Punnett square problem, the third way that we learn to factor. When we learned to factor doing the Punnett square, first step was to identify A, B, and C. So I like to write them out. And then remember that we want to find 2 numbers that multiply to AC, and A times C is 2 times negative 15, which is a negative 30. And we want those same 2 numbers that we find to add to B, which is the number 7. And I'm just going to write next to them that 30 is A times C, so you know where that came from, and 7 is just your B, so you know where that came from. So let's take a moment, think about those 2 numbers that would multiply and add. And in this case, I found that they were 10 and negative 3. Remember that they have to work, guys, for both equations. So 10 times negative 3 multiplies to negative 30, and 10 plus negative 3 adds to 7. Once I'm done finding those 2 numbers, I'm going to go to my Punnett square. Inside of our Punnett square, the first box gets our first term, so that was 2x squared. And our last box gets our last term, which is a negative 15. And then inside of those middle 2 boxes goes our magic numbers. Doesn't matter which way we write them. I'm going to put a 10x up here and a negative 3x down here. But again, doesn't matter. Then we can start by looking across the top row and pulling out a greatest common factor. Well, 2 goes into 10 and 2, and they both have an x. So 2x is the greatest common factor on the top. I want to look at my top left box. 2x times 1x is going to get me a 2x squared. Then I'm going to look at my top right box. 2x times 5 is going to get me a 10x. And then I'm going to look at that bottom left box. 1x times a negative 3 gets me a negative 3x. And that last box is just a check box to make sure that it works. Negative 3 times 5 does get you a negative 15. So once I have those 2 answers, I'm going to write them out separately. But remember, in my equation, we still had 0 equals. My first answer, I just read right across the top, so that's 1x plus 5. And my second answer, I read down the side, and that's 2x minus 3. And now I can go ahead and perform that 0 product property. So I want to split these guys and set them each equal to 0. So my first one is 1x plus 5 equals 0. Doesn't matter which side the 0 goes on. And then the other one is 2x minus 3 equals 0. So let's solve the first one first. I want to subtract 5 on both sides. And when I do that, I just get 1x, or just x, equals negative 5. My other one, I have to add 3 to both sides first. So I have 2x equals positive 3. And then that 2 is in front of the x, so I want to divide it. And I get x equals 3/2, or 1.5. Now that I have those 2 numbers, I have to do step number 4, which is to take my answers and write them as coordinates. So my 2 answers are negative 5, 0, and my other answer is 3/2, 0. and that's your final step. Make sure that you show all of your work for these guys because there are a lot of steps here and a lot of places that you could go wrong if trying to do it in your head. Okay, one more that I want to try together is example number 3. And we're going to do those exact same steps here. So step number 1, we're going to take our y value and we're going to just substitute 0 in there. So I have 2x squared plus 12x plus 18. Next step, I want to go ahead and factor. So I factor by pulling out the greatest common factor first. In this case, there is a greatest common factor. That number is 2. When I take that 2 out, I'm left with x squared plus 6x plus 9, sorry. Now that I pulled out my greatest common factor, I ask myself, is this dots or does this look like a Punnett square? Because there's 3 terms, I know we're going to go ahead and do our Punnett square. So I'm just going to go ahead and label my A, B, and C. A in this case is just the number 1 up front, B is 6, and C is 9. So step with my Punnett square, I want to find 2 numbers that multiply to A times C, which in this case is 1 times 9, which is 9. And remember, that's just your A times C. And then I want to find those same 2 numbers that add to B, which in this case is the number 6. So take a moment, think about those numbers. In this case, it's pretty simple. 3 times 3 multiplies to 9, and 3 plus 3 adds to 6. So I can go ahead and make my Punnett square. My first box gets the first term, but remember that we pulled out the greatest common factor in the beginning. So we are using our new equation up here that we already factored out, our GCF, in our Punnett square. So my first piece, my first box is going to be that new x squared, and the last box is going to be that new 9. And then inside of my 2 boxes go my magic numbers, 3x and 3x. Okay, I want to start by looking across the top row and pulling out the GCF. There is no number that goes into 1 and 3 except for 1, but I can pull out an x because they have that in common. On the top left box, x times x gets you x squared. The top right box, x times 3 gets you 3x. And on the bottom left box, also x times 3 gets you 3x. Use my little checkbox, 3 times 3 gets me 9. So I'm going to go ahead and write those 2 answers out. So remember, we had 0 equals, we still had that greatest common factor of 2 up front that we pulled out in the very, very beginning. And now I read across the top, x plus 3, and down the side, also x plus 3. Okay, time for step number 3. We just factored. Now we're going to move on to the zero product property. So I'm going to split up my pieces that I have here, and I'm going to set each piece equal to 0. So my first piece is 2 equals 0. Second piece is x plus 3 equals 0. And the last piece is also x plus 3 equals 0. Now notice, just like in the first one that we did, guys, this 2 equals 0 is not true, so it really doesn't give us any answers, and that's because there's no variable in that very front piece, so we kind of just disregard it. But our second and third pieces, we can do some math here by subtracting 3 on both sides, so I get x equals -3. And same thing here, I can subtract 3 on both sides, and I get also x equals -3. Now, because these answers are the same, we only have to write that coordinate 1 time, because that's 1 point on our graph. Remember, if x is -3, we plugged in 0 for y, so y is 0. And that means, in this case, guys, there's only one x-intercept. So if you look at those graphs at the top of your notes today, you'll see that only one x-intercept just means that you're only going to have that vertex touching your x-axis. Thanks, guys.